So, in the last session, let me just do a brief recap. So, in the last session we had looked at how do you store data in a graph database. So, we had taken a small unstructured data and put it into the graph database, which is the Neo4j graph database. And then we said we will use this graph database to retrieve and answer queries. While that is a good approach and a good way to show this, what we are doing is a small alteration. Instead of dealing with unstructured data only, which we will do separately, we are dealing, and since we have done that already with RAG, we thought that we will deal with a little bit of structured data, and can an LLM handle structured data? Because this question was often asked. See, LLM is good if you have everything in English, everything is unstructured, and then it can answer queries from that. That is what we saw in the RAG story also. But what about answering queries in English which are asked about a little bit structured data, which can come from a CSV file, or which can come from a database, or which can come from anywhere else? Is an graph database and an LLM capable of answering questions which are coming in a structured data? So, we decided to take a structured database consisting of a CSV file which is about movies, actors in the movie, directors of a movie, genres of a movie, rating about a movie, so that we can take this data and I can show you how to put this data in a graph database. Now, this data can come, like what we are doing right now is from a CSV file. The CSV file can be exported from a MongoDB, or the CSV file can be exported from an SQL DB. So, it can come from any source of data, or it can come from even unstructured source of data. So, we are taking the CSV file as our primary source of data in the fond hope that it is more generic. And as I promised you before, I am going to show you how to build this CSV kind of data from web crawling and all that kind of thing, or how to build unstructured data also from web crawling. That is a process I need to show you. So, setting the ground rule, we are going to work with a substantially structured data to deal with movies. Take that data, load it into the graph database, and then use queries via an LLM to retrieve data from that. Okay. So, that is going to be the thing. Now, this notebook that we are going to give you for running this obviously starts the same way our earlier notebook started. That is, we are going to use Neo4j, and so we need the URL of the Neo4j, and then we need the username, and we need the password. So, this is all to set up the connection to the Neo4j, which will be installed on the, which is installed on the DGX, and that will be acting as our graph database. So, anyway, this is simple enough. So, now this diagram actually tells us quite a bit about what the way it's going to be and how an answer is going to be done. So, let us spend a little while. How do you do GAG, graph augmented retrieval? So, let me try and elaborate how this happens. So, the presumption is that we already have a graph database which has been populated. Now, how to populate this also we are going to show you here. So, it can populate using structured data, which is what we are going to show today, or it can be populated using unstructured data, which we talked about in the earlier session. So, that is the good part of the graph database, that it really is structure indifferent, that is, it can act as a repository for structured data as well as unstructured data. And I am sure you remember from the last session that a graph database basically believes in storing data as a collection of nodes along with their attributes and relationships amongst those nodes. Largely a glorified ER diagram, I mean a simplified ER diagram, entities and their relationship. We call them nodes and relationships. So that is what a graph database will store. Then how does it go about answering English language queries? What is the mechanism it uses to answer English language queries? So we start with the question over here. This is an English language question. So I will say an English language question. That question is given to an LLM because a graph database has no ability to understand English language question. It has its own query language, which will elaborate a little bit as we go down the line. So unless the user is adept at that language, he cannot query the graph database, but that is where the role and the versatility of an LLM comes in handy. So I take the English question, give it to an LLM. Today we are going to use the Mistral LLM, a very popular LLM model. So we take the question, give it to the LLM. What will the LLM do? We will ask the LLM by giving examples using what is called few shot training or a few shot prompting. We will prompt the LLM appropriately, giving a bunch of examples, and make that LLM generate a query which is called a Cypher query. Cypher query is a query which the graph database, the Neo4j, will understand. So this translation is done by the LLM from an English language question using prompting. So lot of prompting will be required, and we will set up the prompts. Of course the prompts have to be set up only once, they are not specific to the question. So we will take the question and the prompting, give it to the LLM. The LLM, which in our case is going to be a Mistral LLM, is going to generate a Cypher query. The Cypher query is, for example, in this case I do not know how visible it is, but we are seeing where n name or is it yeah, the name. So we are seeing Tom Hanks has acted in which all movies. So we are saying we are fixing this person as Tom Hanks, and we are saying he has acted in which movie, which relationship does Hanks have with movies. So all those movies we want to return the title of those movies. Anyway, that is not so important. You can think of it as a question has been translated by the LLM with adequate prompting into a Cypher query. Now that Cypher query is something which can be used in conjunction with the graph database. So that query goes to the graph database, and the graph database produces some kind of an answer which is in its own output. Now that output may not make sense to a lay user. So the output of the graph database query also has to be given to an LLM to produce a English language answer. So it will produce a English language answer which a layman can also interpret and understand. Okay. So this is what is a typical graph database working that we have seen here. Now I will summarize this very quickly. So we start with a layman English language question. We are querying, it does not matter whether we are querying structured data, unstructured data, as long as it has been captured and put into a graph database. So the way it works, as I have shown here, English language question along with adequate prompting goes to the LLM. The LLM produces a query which is suitable for the graph database. The query goes to the graph database. The graph database responds to the query by responding with the data. Now the data has to be again given to an LLM, which will take the data or the response and convert it into a meaningful English language answer, so that a lay person can understand that answer and we get the answer back. So questions which can be put in this kind of a database is who are the actors in a particular movie, one kind of question, or how many movies has a particular actor acted in which are there in the database. or you can say which movie has the highest rating which has been directed by so and so, or which movie of this genre has the highest rating. So, all these are layman questions which can be answered, and this is where the power of an LLM comes out. So, this is a very interesting LLM application which one can deploy and make good use of, because a regular database cannot do any of these things. A regular database, you have to create an SQL query, give it to the database, it will produce some rows of answers, and you need somebody with a little bit of computer science knowledge or computer science aware person to interpret that data. Here everything in the source and the destination, everything is for the layman, and that was the power of using an LLM. So, this is how it works. Now, we are going to demonstrate just this and how it happens very systematically with structured data. It can also work with unstructured data. Okay. So, let us get down to the coding and the example, but before that let me exit from this mode so that we can scroll down. Okay. So, now we are going to go step by step and understand. Anyway, you will have this PDF, you will have this notebook in a PDF form which you can directly use and directly see. So, let us see what we are going to do. So, I am going to go line by line and illustrate. Okay. So, let us get started. So, again I am going to go and try and do a line by line analysis. So, first thing is obviously we are importing the Neo4j graph database. So, this is instantiating the graph database object. So, whatever I do now will go into graph. Then I am creating a query. It really is not a query in the query, I am not asking anything, I am asking for data to be created, but we still call it a query. We will play this query against the database to store this information. So, let us follow through what this is doing. This is, as I told you, picking up the movie data which is in CSV format and retrieving it and putting it in the graph database. How is it doing it? So, let us start with this. This is all the language which the graph database, that is Neo4j, understands. So, we are saying load CSV with headers from, and we are giving the URL for the place where the CSV file resides, which is some GitHub account of someone which has this movie database. So, as an aside, let us just go to this data file and see how our data looks like. We will quickly look at that data. Okay, I will have to say exit so that we can go there. Here is the data. So, I will try and elaborate on how the data looks like. So, this is some kind of an ID of the entry, movie ID. This is the release date of the movie. This is the title of the movie, as we can see here. Now, there could be more than one actors obviously to a movie. So, all this basically are the actors, important to remember, which will have influence in the way we will write the script. The actors are separated by the pipe. So, you see all the list of actors you can split on the basis of pipe to get the series of actors. Then we have the director of the movie, this person is the director of the movie. Again we have another list with the pipe, which indicates that a particular movie may belong to more than one genre. So, for example, Toy Story is an adventure movie, is an animation movie, it is a children movie, it is a comedy movie, and it is a fantasy movie. So, all these represent the genres, pipe symbol separation, and the last rating is the rating, IMDb rating of the movie, that is in case of Toy Story it is 8.3, whatever the number may be. So, this is how my data looks like. So, just to summarize, I have the movie, the release date of the movie, then I have the title of the movie. First I have the ID, release date, title of the movie, then I have the set of actors in that movie which are separated by a pipe, then I have the director of the movie, then I have the genres to which this movie belongs, and lastly we have the rating of the movie. So we are clear about the way the data is. Now as I said before, this data can come from various places. This data can start with a CSV, or this data may have been pulled from a MongoDB, or it could have been pulled from a relational database, or it could have been created using web crawling from a bunch of sites or a single site where this information is available. It could have been created in many ways. So it has been taken from somewhere and has become a CSV file. So this is the structure of the CSV file that we should be aware about. So I think with this understanding of the CSV file, let us go and understand the script which is written to take this data from the CSV file and pump it into the graph database. Okay. So let us look at that script briefly. Okay. So here is the script which will take this data and pipe it and pump it into the graph database. So we are loading CSV with headers from so and so which we just saw as row. So each row is going to be referred to as row. This is a variable which is getting created. Okay. Now merge. Merge is an operation which Neo4j understands. What does merge do? Well, it does two things. A, if it has a object called movie already there with this movie ID, then it will update it if needed. If it is not there, it will create it. Now we are assuming that a movie with this movie ID is not there. So merge will create it. So if it is there, it will update it. If it is not there, it will create it. So assuming that there is no movie, it will create an object M being the variable to hold the object. The movie will be created with one field called movie ID to start with. So it's one field has been done, and then these fields are set on the movie. So the object is being initialized, release date is set by converting that whatever the release date was there in the CSV into the date format. Title has come from the row. IMDb rating has also come from the row. So we take each row at a time, take the rating, take the release date, take the title, take the ID and create the movie object. So the movie object has been created. Now just creating the movie object is not enough. There are other nodes which need to be created. For example, there is the actor node, there is a director node, there is a genre node, and this movie node is connected with them. So it has relationships with them. So all those have to be created, and we will see after the creation how the database looks like, how the graph database looks like. Now let us see how does it go about creating. Now it is using the for each iterator, for director. Though we know that there is going to be only one director, there is a provision to have more than one directors, because movies can have more than one directors. So it is saying for each director in split row dot director, that is the director column which is there in the movie database, it is being split on again pipe. The example we saw, there was only one director, so there will be only one value, but it can be more. So we are taking a director, we are taking each director, for each director in split row dot director. So we are creating a variable called director. Then in the database what we are creating is, we are not creating a director, but we are creating a person. So we are creating a person object in the database, giving it a name P, and it is going to have one field called name. And what is name? The trimmed version of director. So you remove the white space around director and store it as name and create a person object. So we are creating a person object. for each director we are creating a person object, but this person object cannot hang in air. I mean, this person object obviously is related to the movie which we just created. So now see this, we are creating a relationship here. So we are saying this person has directed, this is to represent a relationship, has directed what? Directed this movie. So this is a source, this is a destination, and the relationship is directed. The direction of the relationship is from the source to the target, and what is the name of the relationship? Directed. Now how many such relationships will be created? That depends on how many directors are mentioned in the row, in that particular row. The same thing follows for creating actors. So for each actor in split row dot actors, remember there is that column called row dot actors, that needs to be split on the pipe, and once we split it, again we create a person object, because just like a director, an actor is also a person. So we say person object, name, trim, actor. We could have also created an actor object, but if you wanted to know who are all the people, persons associated with the movie, then that question would be difficult to answer, because then you would have to look at directors also, you would have to look at actors also. So we are creating all of them as persons. So P person, now here P person, name, actor. So we are creating the actor name as the field, as name, and then we are saying we are creating a relationship which is M, this person has acted in this movie. Again, this person is the source, movie is the target in this case, and acted in is the relationship between this source and this target. Same thing follows for each genre in split row dot genres. We are again splitting the genres, again on the pipe symbol. Again we are creating a genre with that name, we are creating a genre object. So we are creating person object and now a genre object, and associating with the genre object with the movie. But see this association, a movie is the source of the relationship, it is in which genre? That particular genre. So because you created a relationship called in genre, movie is the source and genre is the target. So the relationship goes from the movie to the genre. Here the relationships goes from the person to the movie, from the director to the movie. Okay, so this is how a data is created from a CSV file. It is not very difficult, because if you see, first you are creating the main object which is the movie object, then in association with the movie object which is an anchor object, you are creating actors who are persons, you are creating director who are persons, and then you are connecting the genre and connecting the movie with the genre. So all of this is the scripting that you have to write, which is called the Cypher script or Cypher query, which basically defines how a database can be created from data. This is like, if you will, it is like the Mongo insert statements or SQL create table schema statements. So this is like creating a collection or a schema in Mongo or creating a schema in SQL. So we are creating a schema. Not only will we create the schema, because we are also iterating, in one line we will create the metadata which is the schema and also pump in the data. So data will also go into the graph database as per the schema. So first it will create the schema and then pump in the data as per that schema. So now let us run this and let us see graphically how the data looks like in Neo4j. Neo4j itself offers a tool for us to peep into it and see how the data looks like. So again we will exit here and proceed with this. So we just ran the query on our database, on our Neo4j graph database, and see what we got. Let us keep the chunk aside for a moment. The nodes that we got were we got the first node as genre, another node as movie, another node as person. So these are the three different kinds of entities or nodes that we got. Also we got different kinds of relationships. This indicates the cardinality, but let us not worry about it. So this is the acted in is one relationship, actor acted in a movie, a person acted in a movie, a person directed a movie, and a movie belongs to some genre. So this is the relationships which were created by us and they have been captured in the data. So we are just showing what are the different kinds of data we have. So if you see here, I am currently showing the genres. So this is we are exploring the graph database. So you can see different entities are getting created for the different genres and their names are getting stored there. So sci-fi, thriller, drama, these are all the different kinds of genres which are there: mystery, horror, crime, fantasy, western, documentary, war. These are different kinds of genres which were there in our different database and they have been created. These are just the genres, right. Then let us look at the movies which got created. Yeah, so I will have to get rid of this. So let us click and see what are the movies which we got created. These are the different kinds of movie objects, movie nodes which got created. So the different kinds of movie nodes are Casino, Balto, GoldenEye, Sabrina, Copycat, Toy Story. These are different kinds of movies which got created. Then some persons which are actors and directors, they also would have got created. So these are the these are the persons which are getting created here, who are actors and directors. So let us see who are those. So I have to go into this mode. So these are the various actors and directors which are getting created. Now because there are so many and their names are big, what it has done is it has just put a number there, and on the right hand side you can see the ID and also the name. So Robert Rodriguez is one of the actors or directors, because both come under persons, and then we have the Steve Odekirk, he is another, either an actor or a director. So all of that is also captured. So all the nodes we have seen, genre nodes, movie nodes and person nodes, this is all I am exploring the Neo4j. Now let us see the relationships very quickly. So here are the relationships. Now let us zoom into one relationship. So we are saying the relationship we are looking at is acted in, and this is the kind of query, Cypher query, which it has given. It might be interesting to see how this Cypher query works. So match P, that is the matching has to be done. We are not interested in anything else except that anything which is in relationship with acted in that relationship, we want it to come up. So we return P, which is a relationship, and we are showing for 25 in one go. So a movie, so whenever you say acted in, we have defined this relationship between a movie and the actors. So it is bringing in a particular movie and the actors as in relationship with that. Now the actors it is listing are 612, 613, 614, 615. Remember they have their numbers and all that, they have come in the acted in the person data nodes, they are there. So I think it is very easy to understand. These are the various instances of that relationship which have been created. Now similarly we can look at directed. So if you look at directed, generally a movie is having only one director, but sometimes a movie can have more than one. So Cutthroat Island is directed by 29, person number 29, and person number 29 you can see who is. Similarly some of the movies may have more than one directors. I think I just saw one here is one movie which has more than one director, so those are all persons. So 4 rooms seems to have a bunch of directors, 4 directors actually as per our database. So these are the 4 directors which are there, so that has been captured. So that is a directed relationship, and then we have the in genre relationship in our graph database. So this is the in genre relationship where we say the genre is in orange and the movie is in blue. So Heat is a movie which is in which can be classified as action, thriller plus I think something else plus a crime. So if you see this movie Heat, it is in a genre thriller, that is it can be classified as a thriller, or it can be classified as an action movie or as a crime movie. So this is in short an exploration of the graph database where we have captured data in the terms of their entities which are nodes, and also the relationships between entities, they are all there in the graph database. This output that you are seeing is a visual output, but from a graph database, the Neo4j graph database, that is showing us this output. So that is pretty interesting, and you can store the data in the graph database, either structured data or unstructured data, and then you can run a bunch of queries. But remember, you do not want to ask queries in Cypher query language. You want to be able to ask the questions in an LLM, because you want a layman to be able to ask questions which are transformed into a Cypher query by the LLM, and then you want the answer also to be transformed by an LLM into a layman answer, so that anybody who is not familiar with the computer lingo, he can also interpret the answer. So that is the value proposition. So now let us start going through our code and let us understand how it has happened. So we have run this query and created all this data. All of this has happened because of just this one line. Let me just emphasize that this is that line which has done all of this thing, and which is pretty illustrative if you see, and we can print the graph schema also, which shows what are the nodes and what are the relationships. So it is, if you want to print the schema, better is to see it visually, but if you want to print it, you can see that movie along with its attributes and all of that, and then person, and then genre, forget about chunk that is used for querying, and then it has pretty large list of attributes. Relationships are also there. These are the various relationships, as you can see, this is what we created. So these relationships, they are available in the schema. So you can see all of that. Now we are ready to shoot. Now we are ready to, now the graph database is ready. We have explored the graph database. Now we are ready to write our code, which takes an English language question, converts into a Cypher query, goes to the database, retrieves the data, retrieves the answer, converts it back into English language using an LLM and gives us the answer. So okay, so now let us see whether we could do some of this. Let me erase this and let us see whether we can tell you what comes ahead. Now we are going cell by cell in our Jupyter notebook. We are going to give you this, all of this in a PDF form, and we are going to understand how to do that. Now we are running this, the Jupyter notebook is running on our DGX, but the model, the LLM that we are going to use, we have decided to use it because Mistral is a big LLM and we are using it from the Hugging Face hub. So because we are using it from the Hugging Face hub, you and I and you and us have to create an account on the Hugging Face hub, which gives us access, free access to some of the hosted LLMs which are there. We thought rather than bringing the LLM over here on our DGX and running it on a DGX and adding load to our DGX, we thought that for this exercise we would show you how to use the Hugging Face Hub LLM, that is an LLM which is running there, and use it for our application. So the graph database is with us, the LLM is with Hugging Face, and we are so the graph database is running on our DGX station, that is in our GPU on our A100, but the LLM is running elsewhere. I mean, we can use this kind of hybrid approach also in some of the applications. Now as you can see, I am going cell by cell. So what are we doing here? We have set the Hugging Face token. Here we have set the Hugging Face token, which is an API token which you will get once you create your account and log in into Hugging Face, and then we are saving the token on the Hugging Face folder, the same token. So this token is very important. This is typical API token. I am sure by now you would have used the OpenAI tokens and tokens for various other tools, so you are familiar with that. Now what we are doing is we are taking, as I mentioned, the LLM from the Hugging Face Hub. So we are importing the Hugging Face Hub which has a bunch of LLMs. So we are asking the Hugging Face Hub to give us access to an instance of an LLM, and remember, whenever we take an LLM we have to pass some parameters to the LLM to create stuff for it. So the LLM we are using, we have to give the repository ID. It is a Mistral 7B 7 billion parameter, an instruction oriented LLM, because we are going to give it a lot of instructions, and we are going to kind of give instructions and make it generate stuff according to our instruction, because remember, unless we instruct it, it is not going to generate a Cypher query for us. From English it has to generate a Cypher query. If it has to do that, we have to use a lot of instructions, we have to give it a lot of instructions. So the model that we have decided to use is Mistral 7B, 7 billion parameters instruct model. The task is obviously text generation, because that is what we are going to do. We are going to create answers to our questions. In the first stage we are not going to create answers. From our questions we are going to create Cypher queries. So that is also a task generation. Now a task is equal to text generation, then we are setting the task. Now we are setting the model keyword arguments. The arguments are max new tokens. We expect the response to the queries to be not too big in the first stage, and also the responses to the queries also not to be too big. So the max new tokens that we expect it to generate is 50, which is sensible and low. We are interested in only one answer, we are not going to look at probability here. So top k is only 1. Also you may notice we have kept the temperature pretty low, because we do not want it to get creative. An actor has acted in a movie is a fact, there is nothing creative about it. A particular person has directed a movie is also a fact. A movie belongs to a particular genre is also a fact. So there is very little scope for creativity here, and less creative the better. So it is a very conservative model. So we have made the temperature 0.001. Repetition penalty, because we do not expect too much repetition in the Cypher query also, and also in the final answer. So we have kept the repetition penalty as 1.03. Now some of these things you can play with and also come to a conclusion. There is nothing written as cast in stone. So you can alter the parameters, play with it, see whether you get better results than what we are getting, use those parameters, and they will change from problem to problem, and this is basically changing the hyperparameters of a LLM to work in our own way, and this is something you will have to get familiar with over time, and this is part of the way the LLMs work. So that is what it is. Now let me rub this part and see what we do next. So we are now coming to a very important step. I think we will have to scroll. So now we are coming to a very important step. See, what is our first target? Our first target is when we ask a question in English, we want a query to be generated by the LLM. So now this is not something which LLMs do very often or do every day. Most of the time LLMs are asked a question in English and give an answer in English. Very rarely or very I would say not rarely, but less often do we ask an LLM to tell us what should be the Cypher query for this question, so that I can go with that Cypher query to the database, to the graph database. Remember, why are we doing this? Because our users are going to ask questions in English, whereas our graph database does not understand English, it understands only the Cypher queries. So how do you convert, how do you make your LLM take the English and convert it into Cypher query? So we have to use in this case a special kind of a concept called a few short prompts. We have to give him a bunch of suggestions. So this is why we are saying we are importing a few short prompt template. What does it mean? We have to give some examples of this is the question, this is the query you should generate, this is the question, this is the query you should generate, so that the LLM gets a hang. Oh, whenever I am asked the question, the query has to be so and so. If I am asked this particular question, the query has to be so and so. So I am giving a bunch of questions and I am giving the equivalent Cypher queries, which is a suggestion to the Mistral LLM in this case, that if this query is given, this kind of this kind of question is given, this kind of query has to be created, which will go to the graph database. So question is, how many artists are there? Now this is a graph database equivalent of that. How many artists are there? That means we have to look at the movie acted in. When is because there are two kinds of persons, right? There are persons who are directors and actors. Here I am interested only in the actors. So how do I check that? Match a person who has acted in a movie. So here it will pick up all the people, because I have not put a qualifier on the movie. It will pick up all the people who have acted in movies, and then I am saying I am not interested in them, I am interested in their count. So I am doing a distinct A on the persons, and I am doing a count. So I want to, because I want to know, I do not want to know who are the artists, I want to know how many artists are there. So I am writing this. Seemingly say in a similar way, for many different kind of questions I have created these queries because to get it familiar. Now you can look at these queries in detail, it is there in the PDF. What are they for? They are for basically training the LLM into our query language. So LLM is very smart, you give them these queries and it gets trained. Now you will say, just these queries are enough to get the LLM trained? Well, if LLM is so good, then we can make it do anything. No, there is a precursor to this. Most of these LLMs have been trained in all kinds of code generation. So it is not that the LLM for the first time is seeing the Cypher query. It has seen Cypher queries in the past, only thing is it does not understand Cypher query as Cypher query. It is converting this question into this query, it is understanding it at a conceptual level when I give these examples. I have a suspicion that the Mistral 7 billion model has seen Cypher query sometime in the training phase, in its, when the Cypher query, when the Mistral model itself was trained, at that time perhaps it has seen Cypher queries in the past. So it has kind of some kind of recollection that this has, I have seen this in the past. What we are trying to do here is trying to rejig its memory, revisit its memory and saying, for this kind of question this is the kind of query, For this kind of question, this is the kind of query. For this kind of question, this is a kind of query. So we are giving about 5 or several examples there. I do not know how many we are giving, but about 6 or 7. So there are 1, 2, I think we are giving about 7. We are giving about 7 examples to that, and now we are creating that prompt which is called the few shot prompt template, and then we are creating the so we are going one by one and creating the basic prompt first. So we have that created over there, and now see the way we are creating the prompt. Let's just, so we are creating it in 2 steps. So example prompt is called prompt template, from template, this is the template. User input will be question, and we will expect the Cypher query as query. So it will have 2 parts to it, one placeholder is question, the other placeholder is query. Now we are using the few shot template which is going to be the actual prompt used. So we are picking up first 5 examples, we are not using all the 7. So our example prompt is this example prompt, and there are some suggestions which we are giving to the LLM using the few shot prompt template. So the suggestion we are giving is in the form of a prefix and a suffix. Prefix is what comes before, suffix is what comes later. So you are a Neo4j expert, so we are telling the LLM you are a Neo4j expert, given an input question, create a syntactically correct Cypher query to run. Here is the schema information. So we are going to give information about the schema, and the suffix is that is which comes later, user input question, we are going to repeat the question, and we are going to repeat the thing called Cypher query, and the input variables are question and the schema. So this is what is the thing. Now you can take this, I am not elaborating on this too much. Let me erase this. So basically we are taking, I will make the story small, we are taking 5 examples, we are taking an example prompt which has a question and a query, and we are giving the instruction that the LLM has to act as a Neo4j expert. It has to create an input question and respond to a query. Let us scroll to the right. Okay, I have to. So here is the schema information. Below are a number of examples of questions and their corresponding Cypher queries. So this is the bunch of instruction that we are giving as a prefix to the chart, and let us see, let us go back, scroll back, and then the suffixes, we are going to repeat the user input again, which is question, and the we are going to expect the Cypher query back as an output. So it is anyway going to generate a Cypher query. So we have to give the input variable as question and the schema, because the schema has been mentioned somewhere as a parameter. So I think the name of the schema by default under which Neo4j stores data is foo. So that is a schema which has been created. Now look at the cell number 8, look at this, sorry. Now we are saying we are formatting the question, so we have to give only 2 parts here. First part is how many artists are there, and so we are asking it to be printed, and the schema is foo. Okay, so the question which will go to the graph database will be something like this, the complete thing. Look at this, you are a Neo4j expert, this is the prefix, given an input question, create a syntactically correct Cypher query to run, because we are asking it to create a Cypher query. Here is the schema information, schema is the place where all the graph database by default is getting created, that is foo. Below are a number of examples and their corresponding Cypher queries. This is the prefix, okay. And then you have the user input Cypher query. Here are the examples: user input Cypher query, and let us look at the suffix. Oh, we have to scroll. Okay, let us scroll down. Yeah, so here is the suffix user input Cypher query. Okay, this is all part of the examples, 5 of them. Finally, we are again saying what is the user input. This is the query. How many artists are there? And then we are expecting the Cypher query. So after giving all this prompt, we are going to ask the actual question that we need to ask. This is the actual question which we need to ask, and then we are expecting it to generate the Cypher query. This is the prompt for it to generate task. I hope this is are the examples, and then we are saying the user input, that is the suffix, how many artists are there, which is our question, and Cypher query. Now we are expecting it to generate the Cypher query and show it to us here. So if you run this cell, you will see the equivalent Cypher query getting generated. So can we just run this cell? Yeah, up to 8.
Yeah, it's already.
Okay. So we can see the answer there. No,
After passing.
Like to see it before 9. Oh, sorry. Yeah. So we have okay. So we have created the prompt so far, but we have not given it to the database. So this is the place where we give the prompt to the database. So far we have created the prompt. The prompt we have printed. The prompt looks like given the examples like this, and given this question, give us the answer. So this is the so now what will happen? Okay. So now let us try and understand this cell. Okay. So graph Cypher QA chain. So question answer chain. So let us see what happens here. So now we have to create a chain. Now this is interesting. So graph Cypher QA chain, question answer chain. How are we creating? From LLM. So this is our graph database which needs to be queried because it is a graph Cypher. We are mentioning the LLM. The Cypher prompt is the prompt which we are given, and we are saying verbose is equal to true, and then we are saying return intermediate steps is equal to true, whatever. Verbose is to be more vocal and show us everything, and then intermediate steps are also true. So the question which we will get now, which we are sending, the query which we are sending is what is the IMDb rating for Toy Story, and it will respond in because now an LLM is getting involved. So it is will be interesting to see what the response we get at the end of it. So here we have the response. So let me go out of this mode, show you the response. So here is the question: generated Cypher, you are a Neo4j and all of that. These are the examples we have given, and so the Cypher query, yeah, this is important because we are asking it to show intermediate steps. It has done this. So this is the query which was generated, and because an LLM was involved, it went ahead and created a whole bunch of stuff. What is the IMDb rating for Toy Story? The Cypher query which is used for that is match movie, title is equal to Toy Story, that is it. We are only looking for the movie, and return m.imdb rating. So we are giving the match condition. So it should match a movie on its title, which is Toy Story, and return whatever is the IMDb rating associated with the movie. Now there was yet another question which was given, find all movies released before 1990. The Cypher query is no, no, I think this has got mixed up. Anyway, this is the movie rating which we got, which is 8.3. This is the output we got. Okay, let me decipher this for a moment and tell you what we got. Yeah, so we are just going to show you what happened here. So we took a graph QA chain. I will just elaborate what happened. So it took obviously the input as the graph. It took the Cypher prompt which we have in the document and which I just showed you, which is basically a few short prompt as we call it, which is a bunch of questions and their appropriate queries, and we gave it an LLM, which is the Mistral LLM as a parameter, and what would it have done? So an LLM is used now two times. First is to convert my prompt into a query which Cypher query which goes to the database. So we will see what is the query which got generated, because we are saying intermediate steps equal to true. It will show us what is the query which got generated, and then the query went to the database, produced an answer. That answer was converted back again by the LLM into something we understand, that something a human being can understand. That is what this graph Cypher QA chain did. So it is a very powerful thing what this guy is doing. So it is dealing with the graph database and also converting a human query into a Cypher query. It is doing the question answering and bringing it back in a human understandable manner, which is pretty interesting to see. So let us see, let us see how it went about doing that. So here is the thing which we gave to the graph database. It starts here. So this is where we gave this is the prefix and all of that. The relationship are in the following, all this node. Here is the schema information. We gave the schema, we printed the schema and all that. So I will again allow the scrolling to happen. So here is the examples which we gave. Then we said what is the IMDb rating for Toy Story? That was my question. It responded by giving the Cypher query for that because of the intermediate step. This was the Cypher query which it got created. It pretty nicely did the Cypher query creation. So all our training didn't go in vain. It actually created that query. Now some of you may be wondering, rightly so, what is all this happening here? This is apparently, it has generated some other user input and some other Cypher query, because remember it is a generation system. So it intelligently generates something more. So looking at our questions, it created another user input and partly another Cypher query that didn't get created totally. So the final answer that we got is this from the database. So that is the answer we got, and now let's see what happened afterwards. So this finished the chain. So the English answer that we have got is this. Forget some of the other English which was generated, but the question was what is the IMDb rating for Toy Story, and the helpful answer which came back, Toy Story. It didn't say IMDb rating 8.3. It very categorically, because an LLM was involved in the backward path also, it said Toy Story has an IMDb rating of 8.3. So that is a very meaningful response to give. So this is what was created, and there are a lot of intermediate steps which you can look into, and once you run it you will see that. So well, that is all. That is, I guess, we are showing you another query which can be run against the same database with the same prompt. The query this time is how many movies are there in our database. So we run all this, you will get by and large the same thing. Only thing is the query will change. So you can see here this is our user input and this is a Cypher query. This is all extra which is generated on itself. So it's saying match M to movie and return count. So it did that and it produced a count of 299 and then it will convert that into an answer and show you. Let us see what answer it got. The number of movies is 299. So you see here in the English answer which is converted back into English, it didn't say just 299, it said there are 299 movies in our database, which is a much more polite way of giving an answer than just simply saying 299. Now you know why that happened. 299 went back to the LLM, LLM realized what the question was and connected the question with the answer and said there are 299 movies in the database, because the question was how many movies are there in the database. So somebody has to connect that number 299 into an answer. So we just showed you couple of queries which can run. Are there more? So okay, so let us see if there are more, but you can create a query also if you want. We will create a query on the fly, some query, and we will play the chain again. So we will have to copy that cell, I think. So we will copy this cell below and we will just change the query, because this is the cell which is doing the invocation. So let us say how many directors are there in our database. Okay. Let us see whether we get an answer. So we are printing the response. Okay. So somewhere the database answer is 290, but let us see whether it has created this into a better answer. Yeah, there are 290, you can see there are 290 directors in our database. So that is okay. Now let us be a little more ambitious and see whether it can answer a little more trickier query. We will copy that cell again and see. I am also not sure because I haven't tried it before. Let us ask the question, how many directors, how many movies are there with more than one director? With more than one director. Now this is a tough question. Let us see whether we are able to get an answer. Okay. It ran the query. First let us see the query which was generated. So let us spend a time, it can teach us a bit of Neo4j. So it is saying match movie directed with a person, take two persons who have directed the same movie, and where P1 not equal to P2, return count of that movie. See, very intelligently it has created the query. This is not a trivial query to create, if you realize. So match a movie which is directed by person P1, match a movie who is directed with person P2, directed by person P2, and P1 should not be equal to P2 because we want distinct directors. Return the count of such M. Looks like it gave an answer which is 0. Okay, I am not sure whether that is the correct answer, but it did give us an answer of 0. You see here, it has given an answer of 0. There is no such movie which has more than one director, but we did see a movie which had more than one director. So it is this technology still is evolving. This demonstrates that. So it is saying answer to, I do not have enough information to answer that question, that is what it is saying, but the apparent step is 0. So it got foxed, right. So it is not that smart, it created a query alright, but something happened, maybe the query was not appropriate, or it needs to be, we will leave it that as an exercise for you guys to do, to figure out why this query is not right. So movie directed P1, movie directed P2, I think there are movies which are direct not catching, I do not know why, maybe the query something, let us not worry too much about it. This is all the beginning stages of all this technology, but only thing probably you have to do is tweak that query and you are going to get. But the simple queries it is able to answer. So, so there we are getting an LLM to convert our query into a Cypher query, go with the Cypher query to the database, all that is happening in the chained QA, graph Cypher QA, and the answer is also converted back into an LLM and brought by an LLM into simple English and brought back to us. We have also seen simple queries get answered, complicated queries have a challenge. Okay, we will stop this there.